Hi there. I wanted to spend a few minutes to go in a little more detail on the topic of the crystallization of honey. I've seen a lot of interesting questions and reactions to a video I did many years ago on crystallization. So I found the presentation I gave to my local beekeeper association about 10 years ago, and I've just done a little bit of updating, and I thought it would be neat to share this video with you all. So some of the topics we'll discuss in this video. What is honey crystallization? And is my honey bad because it's crystallizing? Is it spoiled? Do I have to throw it out? Why does the crystallization even occur? How do we want to prevent crystallization? And we'll talk about preventing crystallization for the consumer, the honey consumer, as well as for the beekeeper or honey producer. And then we'll talk about how to resolve the crystallization, and then a little bit on how some people crystallize honey on purpose. So that is a neat little thing. So what is honey crystallization? Honey crystallization is the formation of the sugar crystals in the liquid honey. So I did this talk 10 years ago. The 2014 season, you can see from the jar that I had significant amount of crystallization really right out of the bat. I harvested late that year, and I noted seeing crystals in the cells of the honey super frames. And then, of course, the honey got very crystallized very quickly. So you can see, 100% crystallized after 6 months. And it really made me nervous. What have I ruined my honey? Would anybody buy it? Can I sell it? So I really needed to learn a lot more about what was going on. Is it good to sell, etc. So in order to talk about why the honey is crystallizing, first we have to talk about what is honey. So the first key fact is that honey is a supersaturated sugar solution, and we'll talk a little more about what that means. But there's 180 different substances in honey, chiefly water. Well, not chiefly water. Water is about 17%, and these are average percentages. These percentages are subject to change, of course, but water is about 17%. It can be higher, and that's bad. But that's another problem. So the next thing is the types of sugar in honey. So we're used to cane sugar, the sugar that you buy at the store. That is sucrose. That's that fourth bullet there. We're not dealing with sucrose in honey. We're dealing with fructose and glucose. So fructose is also known as fruit sugar, so that's a little higher. So that's in about the 38% roundabout. Glucose is a little lower, about 31%. You can see there's alternate names there. Very little sucrose. That is probably a key differentiator if you're looking for sweeteners that are not regular cane sugar or beet sugar that you buy at the store. Honey doesn't have all that type of sugar. It has different sugars in it. And I think that's probably why people say honey is actually sweeter than like regular table sugar. Then you have a bunch of other interesting things. And I know the people who are connoisseurs of raw honey really care about these other things. And not everybody, but some people do. When you start talking about the enzymes, invertase, glucose oxidase, that's why people buy raw honey, is because they want those raw enzymes. And that's why it's very important to find out if your raw honey has ever been heated, because if it is heated, it's not raw anymore. The honey in the store, probably, I know it's a lot of honey's labeled as raw. Certainly that hopefully gives you some sense that it's not been heated. But I think knowing a beekeeper and knowing how they handle the honey is probably a really safe way to go, because other honey suppliers may be buying honey from other sources, and who knows how they treated it. So dealing with a person that is the single source of honey, not adding other honeys from other locations into their batch of honey, that gives you more comfort that you know that this honey is truly raw. Another really important thing that will come up here, the pollen and wax, beeswax, is also in the honey, trace minerals and vitamins. So those are the components of honey. Bottom line, honey is a very complicated solution. So what is supersaturation? So again, this is another really key part of the discussion. So supersaturation is when you have a solution that has more dissolved material in the solution that could normally be dissolved into that solvent under normal circumstances. And we'll talk more about the terminology of solvent and solute. But think about, there's some examples there, the rock candy. If you ever did the rock candy science project or in school, where you take very hot water, dissolve as much sugar in that water as you can, let the water cool, put a string into that water, and you will form sugar crystals. And what's happening is that once you've cooled that water, it no longer can hold that amount of sugar, because as you heat things, you can dissolve more into it. So you dissolve as much as you can in very hot water, cool that water, and now that sugar can't stay in that solution. It's super saturated. It has to come out one way or the other. And what you do is when you put that string in there, you're introducing kind of what we mentioned here, a seed, giving it something to start growing on, and then very rapidly you're going to get those sugar crystals coming out of the solution and forming on the string, or the stick in this case. Examples, you can see the kind of that airplane flying by, and it's pushing the air, and that moisture, there's so much pressure in that air. When you compress air, it cannot hold as much water as when it's not compressed. And I think that's when you see like that little cloud there. Snow precipitation is another example where clouds form. This super saturated rain's going to happen. The drops form on seeds, little bits of dust in the atmosphere, and then that's how we get rain or snow. So the changing conditions, and it goes back to Boyle's law from chemistry. When we change the temperature, we change the volume, we change the pressure, then these factors will also change. So, in honey, when we say solution and solute, so what is the solute? The solute is the sugars, and the solvent is water. So if you remember going back to that first slide, we had about 18% water, and the rest of the amount basically is sugar. So you have a massive amount of sugar dissolved in just a little bit of water. That's why it's super saturated. So this is a little quiz we did. It's cut off a little bit. So we want to name the solvent and the solute. So just kind of a little interactive thing here. So get your fingers on your buzzer. So again, honey is the solution. The solute, glucose, fructose, trace amount of sucrose. What is the solvent? It's water, right? So we dissolve sugars into water, and then we get honey. So we'll do a little reverse here. So if we take a solvent of water, and then we take a solute of carbon dioxide and a solute of sugar, what is it that may be in your refrigerator that solution is? We've taken carbon dioxide and sugar and we've put it into water. We get, depending on what part of the country you're in, pop, soda, or Coke. Okay, so we have a solution of seawater. We have a solute of sodium chloride, salt, and other salts too. And I think there's potassium chloride and other salts in there. And then the solvent naturally is water, regular water. So you can take seawater, you can boil out the water, turn it to vapor, distill the water, remove the solutes from it. So here's a hard one. So we have a solute of carbon and a solvent of iron. So we are taking iron and we are dissolving carbon into it. So we've liquefied iron, we've put carbon into it. What do we get? Steel. So steel is a solution of carbon into iron. Finally, my favorite, we have a solute of oxygen, we have a solvent of nitrogen, we get air. So air is mostly nitrogen with a little bit of oxygen. The oxygen is inside the nitrogen, and we get air. I don't know if that one applies necessarily, because I think if we compress nitrogen, I don't think oxygen comes out, but you can argue with me in the comments. So precipitation of glucose. So this is what you see when honey is crystallizing. So one of the interesting things is, remember, honey is primarily glucose and fructose. Only the glucose sugar is going to spontaneously come out of that supersaturated honey solution. And then it follows that if you have a honey that has more glucose, then that's going to crystallize faster. And we'll talk about what types of honey has more glucose than others. So glucose loses some water in the chemical process when it becomes glucose monohydrate. So I think that's something to be aware of if you're worried about your honey fermenting. So yeah, you're going to have a little bit of extra water in that liquid honey. So what do you think provides that seed material in honey? We kind of talked about it, right? When you're getting raw honey, you're getting all the pollen, you're getting air bubbles, you're getting all the bits of beeswax. You may have other crystals, seed crystals that have started. And these are things that are found in raw, unprocessed honey. These are really the reasons why you're buying raw, unprocessed honey, because you want the pollen, you want the little bits of wax, you want all the little bits of nature. And as a consequence, now this solution has little seeds that it can then form crystals with. And one of the other key facts to know is that the ideal temperature for causing crystallization is 57 degrees. So I learned this many times when I left my honey out into the garage in the fall and the early winter. What temperature is your garage? And those probably about 50 degrees. There's a little bit of heat because it's sheltered, but it's cold out, and you leave a bunch of jars of honey out in the garage at that temperature, and it crystallizes very quickly. So you think about where you want to store your honey and what temperature. Don't store it at 57. So as I was dealing with the fact that all of my honey in 2014 crystallized, and I'm wanting to sell it because I obviously don't need all this honey, and I was worried about what was the effect of the crystals going to be when people buy this honey and they can't squeeze it, or it's chunky and sharp. And I was worried that people wouldn't want it. And I actually heard the opposite, as people saw that and said, oh no, okay, I know your honey's real because it is crystallizing. And it makes perfect sense, because commercial honey is going to be microfiltered to remove all the pollen, remove all the little bits. It's going to be on the shelf, and it's going to be liquid longer. And unfortunately, I think that we know that some honey producers also microfilter their honey to remove the pollen, so that you can't trace where the honey came from. So the honey could be coming from China, and removing the pollen makes it hard to figure out if that honey's from China or not. So so when you see the honey that is crystallized, it does give you a little more comfort to know that honey wasn't produced at a vast commercial level, or it wasn't produced with the intention of hiding its origin. So again, because you have crystals in there, you must have had some seed material. And again, raw honey should have pollen in it 100% of the time. Regular beekeepers do not have the capability to remove pollen from their honey. Likewise, we do not have the capability of removing beeswax from honey. When I process my honey, I run it through a double strainer, stainless steel strainer, just like any strainer, a little more fine-grained, but nowhere near as fine-grained to catch any of this. So all of that stuff, 100% of it's going to make it through to the honey if you're processing local honey. The other thing that you can do to prevent crystallization is to heat the honey, because what that does is any tiny crystals that may be in that honey get melted, and then that prevents future crystallization. So, and again, once the honey's been heated, it's not raw honey anymore. The enzymes are not going to be there anymore. So local raw honey should not be heated. Be very careful about heating, and we'll talk about that in a bit. The other thing that tells you is the honey has not been cut or adulterated with corn syrup, and this is a very I think it's probably a very common practice, unfortunately, because if you look at the content, and we'll talk a little bit more, but you look at the content of corn syrup, it's glucose and fructose, very similar proportions to honey. So it's something you could add in, and you're not going to catch, oh wow, there's a lot of this other sugar that shouldn't be here. It's fructose and glucose. It's in there. It mixes in with the honey very well. And again, anybody who owns a bottle of corn syrup, it never crystallizes, but it's a supersaturated solution. But obviously, it's been heavily processed to where it will not saturate, or it will not crystallize. So that gives you a little more comfort that your honey is real if you do see crystallization. So this is cut off a little bit. So why do some honeys crystallize faster than others? So this is another question. And again, every year the crystallization rate seems to be different. Again, that one year the honey was in the hive crystallizing already. It was very surprising. And really, what it means is when we have honeys that crystallize more than faster than others, it's about the amount of glucose in the honey, and the amount of glucose in the honey it changes based on the nectar sources of that honey. So on our little chart here, we have a very high glucose content in the raspberry honey. In fact, if you go online, most of the raspberry honeys that you see for sale have been creamed, and we'll talk about that a little bit more. But creaming is a way to crystallize the honey on purpose. So if you know it's going to crystallize, we may as well crystallize it using a managed process to make it more appealing than having it all the sharp crystals. So those honeys, dandelion nectar, raspberry, star thistle, sunflower, are just some of those that have a very high amount of glucose. So those are going to tend to crystallize quicker. And on the other side, your black locust, sage, and tupelo, those are very low in glucose. So that's again going to affect. Now remember, if you're buying wildflower honey, or if you're probably buying any honey, even if it's advertised as a monosource like a black locust honey or tupelo honey, beekeepers don't have a lot of control typically of where the bees go. I know that when you're talking about honey harvested in orange blossom groves, so from as many miles as the eye can see, there's orange trees. But if you're a local beekeeper, the bees are going to be going where they want to go, and you probably don't have a black locust forest that goes for miles and miles and miles. So you're going to get black locust honey, but you're going to get some other honey in your wildflower honey. So it all ends up being just dependent on the percentages of things. What's interesting, again, as I talked about before, high fructose corn syrup, the glucose content is in that 32 to 40%. So high fructose corn syrup is chemically very similar to honey from a sugar standpoint. Obviously not from the enzymes and all the other really good stuff, the hydrogen peroxide and all the other good stuff that you get in your honey that you're buying it for. So how to prevent crystallization? Again, the first question is, do you even care about it? Again, I think it comes down to the presentation quality. If you're entering into a honey show, if you like to have that liquid honey to work with, you don't want to deal with the crunchy crystals. You may have a squeeze bottle and you're trying to squeeze the honey and it's all crystallized. It makes it harder to squeeze it out. That's something to think about. I don't think I've ever encountered this, but when the crystallization is occurring, remember it's forming. The water content increases in the remaining amount of honey. So theoretically, if your honey started off on the border of the 18.6%, which is kind of that cutoff when fermentation starts, you could get some fermentation after the crystallization occurs. When I process my honeys, I think for the most part the water content is well below 18%, so hasn't been a concern for me. But again, that's more of a factor when you're dealing with local honey producers who are grabbing the honey. Sometimes the honey has a higher water content, sometimes it doesn't. It just depends on how the beekeeper harvested the honey. So that might be a concern. I've never heard of it, so it's something to think about. So in order to prevent the crystallization, you would want to store that honey below 50 degrees Fahrenheit. So that means a refrigerator or a freezer. You always want to have your honey airtight, regardless of crystallization, because you don't want the honey to be introduced to moisture in the air, because honey is hygroscopic, which means it likes moisture. It brings water and moisture to it, so that would make your water content go up. And then again, if you're on the edge of that 18.6%, you could see some fermentation. If you're a honey producer, you're a beekeeper, to prevent crystallization, don't store your supers wet. That means when you harvest the honey out of your frames, you want to make sure that those frames go back outside, let the bees clean those up, get all the last bits of water out of there, Clean them real good. Give it a couple days and let the bees just really clean up those frames, and then you'll be set for next. And I think that probably was my problem in 2014, because I've always made sure my frames were very dry going into winter, and I haven't had a problem since with crystallization in my beehive. You may want to consider using plastic, but I think that probably has an issue. I think a lot of consumers probably don't want their honey in plastic, so maybe not a great idea. If you have a honey that you think is going to crystallize, again, you can just crystallize it yourself, and I'll talk a little bit about that. And then, of course, your other method of preventing crystallization is to heat the honey at 145 for 30 minutes and filter it. But, of course, that honey's no longer raw, so I cannot imagine any honey producer is going to do that, any local honey producer. Now you're just buying, honey off the shelf. So how do you resolve the crystallization? So I'll go through 3 different methods. I'm going to start with the worst methods and go to the less bad methods, or the better methods, depending on your approach. So you could just simply heat the honey to melt those crystals. So if you have a bit of honey and you want to use it in cooking, and you have like your little honey bottle like I have there in my example, and it's got a bunch of rock hard crystals, and you're trying to get that last bit of honey for some recipe, it doesn't matter that you're going to heat the hot honey at a very hot temperature. You don't care about the enzymes. You can use a microwave method, and very, very careful with the microwave, just for a few seconds. And you can see from this example that was a plastic bottle, and it used to stand upright, now no longer upright. So heating a plastic bottle in the microwave with honey is not a good idea. So that itself is not the right way to go for this situation. But it's very fast, just a few seconds, just 5 seconds, take it out, swirl it around, put it back in, 5 seconds, swirl it around, and repeat. It will liquefy. It also will crystallize pretty quickly too, because I think a lot of the little tiny crystals don't get melted, again, because the way that a microwave heats is very uneven. You're going to find that honey is going to crystallize very quickly using this technique. And so within a week or two, it's going to probably re-crystallized up. Again, we worry about heating plastic. We don't want to get chemicals from the plastic into the honey, so don't do that. You're going to get a lot of hot spots that'll harm the enzymes. Again, if you're using honey for cooking, baking, then it doesn't matter, right? Because you're going to heat the enzymes anyway in your cooking process. So this is a very fast method that is not great on the enzymes. So here's a better method. So what you can do is you can take a pan of water, you can heat it to 104 degrees, which is a good temperature to heat honey at, because that is a temperature that occurs naturally in your beehive. So we don't have to worry about hurting the enzymes when we get to 104 degrees. Once you get 104 degrees, you put your jars of honey into the pan. Like you could, with a 104, you could probably do plastic no problem. And because it's a low heat, so your plastic probably won't be a problem. But you put your honey in there, and then now you're keeping the temperature low, and so you have to monitor the temperature. So that's a little tricky, right? So now I gotta put the heat on low, keep checking that temperature, make sure it doesn't get above 104. And then what that water bath is going to do is it's going to just gently heat that honey up to 104 eventually, and then those crystals will be melted. So I don't know why I put faster as an advantage. This is kind of time consuming. You have to keep an eye on it. You have to keep it 104 or below. You got to have a thermometer. Maybe not the best for plastic, or hopefully you have good labels and they don't start peeling. So that's maybe a better method. This is the method I use, which I think is the best method. I think there is some downside to this method though, and we'll talk about that. So in this method, this is the heat and walk away. So I just did this a couple weeks ago on a 4-pound jar. So I got a big pot of water. What you do is you put the jar in the water in the pot, and then you fill the pot with the water until that jar starts floating. And you obviously don't want a jar of honey floating in your water. So once that jar starts, you feel like it's starting to float, that's just pour a little bit of that water out. That's enough water. So put that water on the stove, take the jar out, heat that water up boil the water, get a good boil going, and then once that water is boiling, you can take it off the heat and then put your jar in the boiling water and then just walk away, and it will be done when it's done. So all that 212 degree temperature water, that heat is going to find its way into that honey, heat it up, and then melt it. So again, downsides is that if you're very concerned about enzymes, this is not probably the way for you, because what's that? How hot is that honey getting inside? Now, it's not all going to be 212 degrees immediately. That heat's going to transfer from the water into the glass, into the honey. So I think, the question is how hot does the honey get next to that glass inside that jar? And I don't know the answer to that. I don't have a thermometer that can test that. But is that temperature higher than 104? It very well might be. So if you're worried about enzymes, I think there is a good chance that your enzymes are going to be harmed in this method. Maybe that second method we talked about would be better. Maybe you take the jar out every few minutes and just kind of slosh around the honey a little bit so that you can keep the high heat off of the sides of the jar and try to circulate that honey inside the jar. Maybe you have the lid open and you just get a spoon in there and just kind of stir it around. I think that way would be a lot better. Maybe even insert a temperature probe inside the jar of honey, just to, again, monitor that temperature. But the big advantages to this method is it is a walk away. And I can do a large quantity. I have a big pot. I can do 4 pounds, stick the thing in, and again, walk away and then come back in an hour, and the honey is very nicely liquefied. For our purposes, we're not too concerned about the enzymes because that honey is going into a hot tea. The hot water of the tea is probably 165 degrees easily. So the enzymes are probably not going to survive that. So for us, it doesn't matter. So that's kind of the way we go. So now we'll talk a little bit about how to resolve crystallization if you're a beekeeper, honey producer. That's the word that's cut off up there. This is a method I used actually in 2014. So again, picture having a big harvest of honey, a big 5-pound bucket of honey, and it's got seed crystal already in there because the honey is already crystallizing in the hive. I extract it, I store it in a bucket, and then it just turns into a big solid mass of honey crystals, and that's exactly what happened. So this is a method that I did, and it worked really well. I went and got some R4 insulation, so it's that pink sheet, and I just bought it at the home improvement store. I got a thermometer. I got a light bulb from a Christmas decoration, and I put in a low watt bulb, something between 25 and 40. You get a little bit of duct tape, and you can build a box out of that R4 very easily, and then simply put your honey in there and turn a light bulb on and monitor the temperature, and it will get that honey liquefied. Here's the data I collected when I did this, so you can see the setup. Again, I did it with a gallon jar. You can see the crystal level on day 0 was about halfway. I turned the light bulb on, I monitored the temperature, and I found that I was getting that 104. There was one point when I exceeded that temperature, but really did a nice job getting to 100 degrees, 104. The insulation of that box keeps that little bit of heat generated from that incandescent bulb inside. Good point, actually. You're going to want to use an incandescent bulb. That might be a problem these days. I think back in 10 years ago, getting an incandescent bulb at the store was not hard to do. So I think probably not going to work with an LED light bulb, unfortunately. So important when you have a light bulb that's hot is, make sure you don't let it touch the sides, because this is the problem I had. That light bulb melted right through my R4 plastic, so maybe not a good move there. Other approaches, there's a URL to some plans. You can see that there's a more robust warming box with wood and screws and handles and proper electrical and insulation on the inside. So that is a method. Another method I've used is what I call the hot car method. So I've done this, and this works on really a sunny day, which doesn't happen very often in Michigan. But you can take your crystallized jars of honey and put them on the dash of your vehicle on a sunny day, and that will melt the crystals in your honey or in the seed. That's worked very well. Haven't tried hot water in a tub. I don't think I would pursue that method. And then if you go on beekeeping supplies, you'll see that there are bucket warmers. So when you have that 5-gallon bucket full of honey and it crystallizes, you put one of these things on it and it'll heat that honey right up. So I think one of the last things we want to talk about was the purposeful crystallization of honey. So, again, maybe you have a honey that in your area crystallizes very quickly and you don't like it. You want to maybe leverage the power of crystallization to produce a higher, kind of a higher finished product, if you will, which you get with creamed honey. Creamed honey is very, very delicious. It's the same honey, but what you've done is you've created crystals in the honey, but their crystals are so small that you have a creamy texture to the honey. You don't feel any of the graininess. It is like almost like marshmallow fluff if it's done very, very well. And what you're doing is basically saying, well, if the honey's going to crystallize anyway, I may as well dictate how the honey is going to crystallize in order to produce a product that is crystallized and is ready to go, and you don't have to worry about it, anything else happening to it. What you do is you would follow what's called the DICE method. I think this is the name of the person that came up with this, DYCE. And there's basically the process of creaming honey deals with first heating the honey. So again, if you're buying honey that is creamed, then you know that it's been heated, so it's not raw anymore. So if that's important to you, then creamed honey is not for you. But we are heating honey to about 120 degrees. We're straining it. Again, the heating is melting any residual crystals, and then what you're doing is then you're cooling it very rapidly. So you get it down to about 75 degrees, and then what you're going to do is you're going to get 10% seed crystal that you're going to add to that honey. So what that means is if you have a kilogram of honey, you're going to add 100 grams of seed crystal into that honey, and then you mix that in, you get like a corkscrew mixer, and you're going to introduce those seed crystals throughout. And what is going to happen is that crystallized honey is going to form the same crystal pattern that you've just introduced with your seed crystal. So what you're going to want to do is you're going to get a good creamed honey that you like and introduce it into this batch, and you're going to get that same creaminess out of this honey that you did with that. Just again creating those very, very, very tiny fine-grained crystals. So once you've introduced, you've added 10% by weight of a seed crystal of a creamed honey, you're going to put this at, again, our magic number, 57 degrees. You're going to put it someplace cool, achieve 57 degrees, and it will crystallize like nobody's business. It will crystallize very, very quickly. It's remarkable how fast it crystallizes. I know it says here about putting it in a food processor. I haven't had that issue. I haven't had to use a food processor when I've creamed honey, so I don't know why I have that in there. But what I do is I use a wide mouth jar. So I take this new mix, I pour it into a wide mouth jar, seal it up. I've put it in like a cooler with some ice, or just again cold garage. And if it's not 57 degrees, it's fine. But it just needs to be at a cool temperature around 57, and it's going to cream right up. If it's at 80 degrees, forget it. It's not going to work. So I like the wide jar because you can open it and you can immediately see, okay, it's crystallized through and through. And now you have a product that you can, kind of a higher quality product that you can sell. Other examples of purposeful crystallization that you may be familiar with, ice cream is an example, where you put the cream into a freezing the freezing thing, and it creates, when the little dashers are spinning around, it's taking very minute, tiny crystals off the side of that dasher. That's how ice cream is creamy. Whereas if you just took the cream and sugar and flavor and just put it in the freezer and pulled it out, it would be kind of gross. The magic is in the tiny crystals that give you that mouthfeel that you really love. Also, creamed maple syrup is a thing. Maple syrup is also a super saturated solution of that sap in a solution of water. So you can cream maple syrup as well, and I think that might be a fun little project. So these are the references that I used to do this presentation. So you're happy to go and check those out, and I recommend those. And hopefully this has been a very helpful presentation to get a deeper dive into what honey crystallization is all about. Is it bad or not, and what you can do to resolve it or embrace it. Thank you so much.